Hello, everybody, and welcome. We're continuing the discussion of the robot hand. This is a robot hand that is a mimic of a human hand. I try to send my videos to my YouTube channel. I invite you to subscribe. I think you would like it. I do have a website. You can go to the website. There's a page there. That page has images of the robot hand and an FBX set of FBX exports of the 3D drawing files. I do mention anything you create that's physically real might hurt somebody, so if you can't properly manage it, then I advise don't make it as a physically real item. The human mimicking robot hand, I think, should be about the same size as a human hand, about the same power as a human hand, about the same dexterity as a human hand, and I think it should be able to run or work for 6 or 7 years without needing to have its parts replaced. And let's see what Bing has to show us. This is a koala. It is my hope that I'm not having this effect. He seems pretty happy. I have to go quickly and try to keep it interesting. I've pulled the hand drawing into Maya, and I'm just sort of tuning up how it looks. And this is the hand. There's you can see I have already talked about the fingers and the hydraulic cylinders that move the fingers around. And this is a discussion really about the thumb. The thumb is what allows the hand to have pinch effect. And you can see over here, the thumb is completely up under the palm. This would be the fingernail of the thumb. That's the pad of the thumb. And these would be the fingernails of the fingers and the pad of the fingers. And the fingers can curl down and the thumb can curl up to give you pinch, like pick up a toothpick or put mascara on or use a pencil. But the thumb, you can see, is up under the palm. And that's what allows it to do that. And if you want to do something like a push-up, or if you want to push a door open, or if the robot fell down and want to put its hand on the ground and push itself back up again, you need to get the thumb where the thumb is not up under the hand. And that is the next thing that we're working on here. And here you can see the thumb is moving laterally and even more laterally, so it's no longer under the hand, and now the thumb starts to move up. You can see it's moved up some. It's still a little bit in the plane of the palm, but here it's moved completely up. And is out of the way of the palm. So if the palm was on the ground, the thumb would not be. And this drawing, the FBX of this drawing is 770 megabytes. I tried to put that on my website, but it's too big. A couple of other things that are just interesting. The thumb can rotate. You can see here that the fingernail of the thumb is back, and the angle of the thumb with respect to the palm is on this angle, and that's so it can touch the fingertips. And that rotation of the thumb to allow that is controlled by this hydraulic cylinder. This hydraulic cylinder rotates the thumb around this bolt. That bolt is got the bushing bearings in it, so it acts as a radially axially stabilized thrust bearing. And so as you can see, this hydraulic cylinder here has extended itself, and when it extended itself, it rotated the thumb out to horizontal. And this is all done with these hydraulic cylinders, and the stabilization. The thumb does have the same flexion and extension and abduction and adduction that I've already described for the fingers, but it also has this separate structure that anchors it to the wrist. And this is done with 2 hydraulic cylinders with cardanic joints and a third one, so that you have a triangular shaped stabilization so that the thumb won't move around. The cardanic joints, if you put a twisting motion on them to put a bend on these shafts, the cardanic joints just move. So when you have a triangular shaped stabilization like this, the only forces acting on these cylinders are either compression forces or tension forces. And I did make a smaller, and here are the little ligaments here. These ligaments are what create power motions. This ligament would curl the finger down, and this ligament would curl the finger up, and you have a similar ligament on the thumb. I did create a smaller image that has fewer hands in it, and that is on my website, where you can download that as an FBX file if you want. I try to keep the videos less than 15 minutes so I can send them to LinkedIn. I think that's kind of fun. I do believe there are people who will say the type of a hand that you're trying to create with all of these specifications is not possible. But I think it is possible. I think I can demonstrate it. But it's a series of short videos. So there's a video about the fingers, a video about the thumb. I'll do a video to show that it has enough strength. And I'll do a video to show how the hydraulic cylinders can move it. And I'll do a video to show how a central processing unit would be able to monitor these hydraulic cylinders and control them in a digital manner. That's all just a set of videos that I plan to prepare for you. All right, and this is the smaller Maya file of the smaller drawing. And I'm just tuning it up a little bit. And it doesn't have as much in it. It has the thumb that's curled up under the hand and the thumb that's fully out. I also put the thumb in here, the hand in here showing the thumbs up position. I think the thumbs up position, I'm not sure how often the robot would use that, but I think it's cool looking. It does show how the fingers are rotated down, and that's important to see. The phalanges, these are the phalanges. Here's a phalange right here. That's the distal phalange, that's the middle phalange, and that's the proximal phalange. That's the metacarpal phalange. And I'm using the terms of human anatomy because why not? It's sort of like robot anatomy. But when this particular ligament, all of these ligaments go back to very strong muscles in the forearm. And when this one is pulled, as it shortens, it runs through these pulleys and it curls the hand over. And this gives you the strength of the hand. If it was holding on to a bar, this wouldn't be down that far. But this, in order for the hand to lift up 200 pounds, it needs to have 50 pounds of force on each one of these 4 fingers. And I did a force analysis on it. I'll do a video about that. But this pull here is about 112 pounds. If you put 112 pounds of pull on this, then you can push up this way with 50 pounds of force, and it will tolerate it. And the little parts of the robot are all able to withstand those kind of forces. And I will do a lecture on that. I call it a force lecture. And it will show you that these parts are strong enough to do that. They're not strong enough to go out and break apart a concrete sidewalk, but this isn't an excavator. This is a robot. And this part of the hand can move this way and that way. It can also move up and down. That is controlled by these four, let's see here, these four cardanic joint. The three of these on the hand are cardanic hydraulic piston, and this one is a fixed one. And these I used a green coloration as the structural element that provides support, and I call this the magic hand. I created this myself. All these little parts are independently movable, so I can put the hand in whatever position I want to put it in just to show things. I do have an image of this that I created in KeyShot. Let's look at it in KeyShot. And again, we would say, hello, Mr. Koala Bear. This is KeyShot. KeyShot makes it beautiful. You should wake up. This is the version of it that I used to create the thumbnail. And what I did was I took the other two hands and made them invisible. And here they are back again. Now, you can see these are the number of samples. And as the samples go up, it becomes prettier. And this is using KeyShot. It's an image editing, image processing program, and it just makes everything look beautiful. But it has to run the light to get the light effect. So it's trying to make it look real. And I just think it's pretty. Now, again, all of my drawings, I lower the opacity of the, this is all just going to be metal, gray metal, but I lower the opacity and add color so you can see which parts are which. And as I lower the opacity, it lets you see through the parts so you can see how things work. And that's just something that I do. And here's that little ligament curling the hand over for the thumbs up. And KeyShot will allow you to render out an image, and there's some images on the website on that page. I think I did one 14,000 pixels by 10,000 pixels. It's 247 megabytes. It's fun to look at, but I think that's a little large for the website. We'll see if we can pull that up. So this is the 240 megabyte PNG, and it's just fun to me. This comes very close to being artwork. I have to be careful. I created it, so of course I think it would be pretty. There's another one I did that's 127 megabytes, and that one is available on the website for you to download. All my downloads on the website are for free. This is the 124 megabyte image that's available. It's a PNG image. It almost allows you to look inside of these cardanic joints to figure out how they work. This part of it allows this to go back and forth that way, and this part of it allows this to go back towards the back and up towards the front. And again, I think the thumbs up thumb is just kind of cool. It's not, I don't know when the robot would use that, but you got to admit that looks pretty cool. Anyway, this is available if you like this, if you want to study it, if you're trying to figure out how this hand works. I'm going to show you how this hand works. This is not a hand that's magic. This could actually be created. I don't think it would be inexpensive, but I never said it was going to be inexpensive. I said it was going to duplicate a human hand. Anyway, thanks everyone. And the lady, you know, women, they have that way of looking at you saying you're done. So I got to go, and I'll have another video for you soon enough.